Okay, so this is problem 24.10 from homework 3, and they've given us this figure here, and they want us to calculate the electric flux. Yes, what is the electric flux running through the surface? And they've given us the electric field strength as 340 newtons per coulomb. They've also given us the dimensions of the surface equal to 100 centimeters squared for the area, and then they've shown the electric field coming out of the surface at 30 degrees, and then here's our unit vector running normal to the surface, or perpendicular to the surface. And then to calculate our electric flux running through the surface, we're going to use the surface integral of the electric field times the area vector. And then to simplify that, we can just take the magnitude of the electric field as E times the cosine of theta, because that's going to show us the component of the electric field that passes through the surface. And then our theta will just be equal to the normal, or this unit vector n hat, the angle between that and the electric field. So we can just take that 30 degrees, subtract it from 90, and we know that it's 60 degrees is going to be our theta. And then furthermore, we can take the e cosine of theta outside because it's a uniform electric field, so we know that's going to be constant throughout. And then we know that dA is just going to be equal to the area of the surface, because it's just all the little pieces put together, which is just the area. So yeah, so this is going to be the equation that we want to solve for, and that's the electric flux equal to electric field times the cosine of theta times the area. And we have all of those numbers, so we can just plug them in. 340 for our electric field, cosine of 60, and then times that by the 100 centimeters squared. Now be careful here, because I screwed up the first time around because I didn't square when I was converting to my meter. So be careful here, because you know, if we're taking a square, we need to remember to square that when we're converting. So yeah, just take that times 10 to the negative 2 meters over 1 centimeter squared, and we get our electric flux equal to 1.7 newtons times meters squared over coulombs. And yeah, that all ties into what we're learning in chapter 24 with Gauss's law and calculating electric fields through surfaces.